Students, here I am with you making this video primarily for my online students in statistics. I'm going to do all of the homework problems. There are 10. I'm going to do all 10 homework problems from the week 6 homework, and that is the topic over hypothesis testing. But I have here a warning. Please read this. You're not going to learn any statistics from this video. That's the primary reason I've not ever wanted to make this video, is because you aren't learning any statistics. It's just me training you to use a piece of statistical software to get numbers so that you can do your homework. I'm upset to have to make it. I feel ashamed. Because I would much more prefer that we learned where those numbers came from and how to interpret them. That is statistics. Just getting them, that's nothing. That's just a task. At any rate, I'll stop complaining now. Here we are. This is question 1 from the week 6 homework. It is hypothesis testing about a proportion. You can tell that because of this little p, just like in week 5. Let's see what's going on here. 100 colored candies were selected. I saw that 25% of them were blue. They claimed that 23% of them are blue, and we're going to test that claim. So they didn't say check to see if it's more than 23%. They didn't say to check to see if it's less than 23%. So then this is our initial and alternative hypothesis. Identify the test statistic for this hypothesis test. All right. Well, I'll get Statcrunch open. You can do that by going to the Get More Help down here, clicking on Statcrunch, and then the Statcrunch window will open up. So here is my Statcrunch window. I'll just make it bigger. Now, I'll go to Stat, Proportion Stats. How would I know it's proportion stats? Well, the answer choices all had a p. All of the hypothesis tests were about p. This is proportion stats. So I'll go to Stat, Proportion Stats, one sample with summary. I don't have the raw data, so I'll go to with summary. I click the button. Now, what was, so here they want to know about number of successes and number of total observations. Well, what was a success in this case? It was finding a blue candy. We found that 25% of them were blue. 25 out of 100. 25 divided by 100 is 25%. So there was 25 of them blue out of 100 total candies. Okay, and then look, the button for hypothesis test is already picked. And I know what to put here because I already did that in part A of the question. It's either equal to 0.23 or look, it's different from 0.23. I click compute. I get my test statistic. I get my p-value. Super. So going back over here then, I shall say that the test statistic is 0.48 because it's rounded to 2 decimal places. 0.48. Good job. Find the p-value. Well, it's 3 decimal places, so 0.635. Super. Okay. Now they want the conclusion. Okay. Here is the very shortest, most simple, easy to remember thing that I can give you to help you with your conclusion. I mean, it rhymes. It rhymes. I would hope that helps lend itself to being remembered. If the p-value is low, reject H0. H0 being the initial hypothesis. How low? How low does it need to be? Well, it needs to be lower than the significance level. Here, the significance level, 10%, 0.1. My p-value, 0.64, basically. It's like there's a 63.5% chance that I would be wrong to reject H0. It's way higher than this significance level, so I shall fail to reject. Every single time I fail to reject, there's insufficient evidence. Insufficient evidence to what? To reject. All that stuff I highlighted right there might as well say to reject H0. All of that stuff right there might as well say reject H0. Then this thing would read, fail to reject H0. There is not sufficient evidence to reject H0. Next question. This is number 2. Suppose that 242 subjects are treated with a drug used to treat pain. Okay, great. 54 of them develop nausea. My significance level is 5%. Test the claim that more than 20% of them develop nausea. That's this hypothesis test. Initially, it's equal to 20%. Alternately, it's greater than 20%. Okay. Identify the test statistic. Okay, so I would get my Statcrunch open. Here it is. This is still hypothesis testing about a proportion. Proportion stats, one sample with summary. They want to know the number of successes that we saw and the number of observations. Now, the thing that we're trying to test here is developing nausea. So, in this case, a success will be someone developing nausea. There was 54 patients that developed nausea out of 242. My hypothesis test would be that P was equal to 0.2 or that it was greater than 0.2. Okay. Come back here just so you can see where all these numbers are coming from. I click compute. It gives me my z-stat and p-value. Okay, so my test statistic, 0.90. My p-value, 0.184. Time for the conclusion. If the p-value is low, reject H0. This p-value is 0.18. That's a lot more than 0.05. The p-value wasn't low. So I will not reject H0. I'm going to fail to reject. Every single time I fail to reject, I do not have sufficient evidence to reject H0. All that stuff highlighted in blue might as well say, it says exactly to me to reject H0. I mean, the actual words that are printed there say, you know, warrant support of the alternate hypothesis. Well, to warrant support of the alternate hypothesis means to have rejected the initial hypothesis. And if I fail to reject the initial hypothesis, there is not sufficient evidence to reject the initial hypothesis. It's exactly straightforward. I mean, it seems almost like a redundant statement. I could not reject because I do not have the evidence to reject. Question number 3. We have a poll of Americans. There's 1,069 of them, and it showed that 47.1% of those Americans preferred to watch the news rather than read or listen to it. Okay. Super. Now, if I was doing this by hand, I would have everything I need to get the problem done, but they've used this number that they've said that 47.1% of this many Americans want to watch the news. And I'm testing the claim that less than half prefer to watch the news. Okay, so it'll be that this is equal to a half, or that it's less than a half. Since they have quoted, they didn't tell me how many successes there was, right? I have to figure that out. But to figure that out is the type of problem that you would have done on your entrance exam. It's the type of problem you would do to see how much an item would cost if it's like, 30% off or something. And this would be even easier than that type of problem. To know how many people responded, we want to calculate 47.1% of 1,069. So I'm going to get my handheld calculator. And I find that it's roughly 503. Perhaps I could round up to 504, but I won't do that. I'll just say that there were 503 people out of 1,069 people. And I'm testing the hypothesis that it was equal to 0.5 or less than 0.5. My z-stat is a minus 1.93, and my p-value is 0.027. Time for the conclusion. Well, significance level is 5%. This, 2%. It's low. The p-value is low. I'm going to reject H0. That means there is sufficient evidence to support the alternate or reject the initial, whichever way you want to phrase it. They mean the same thing. So I'll look here at this. What are they talking about here? They're talking about the claim that fewer than half, the claim that fewer than half, the claim that fewer than half. That's the alternate. Well, we rejected the initial. That means we support the alternate. All right. Question number 4. In a study of cell phone usage and brain hemispheric dominance, they emailed this many people. There was that many surveys returned. This is our significance level, and we're testing that the return rate is less than 20%. Okay. So I'll return pstats 1 sample with summary. Here it is. There was 1,339 people out of 6,988 people. Test the claim that it's equal to 0.2 or less than 0.2. Compute. There's my z-stat and p-value. I guess I need to decide which one of these hypothesis tests it is. So we're testing the claim that it is less than 20%. So it's this one. The initial hypothesis is always equal. The alternate is either less than, greater than, or not equal to. All right, so that's the one I want. And get my Statcrunch back up here. I see that my test statistic is negative 1.75. I see that my p-value is 0.040. Super. 0.04 is not less than 0.01, so the p-value is not low. I will fail to reject. So because the p-value is greater than the significance level, I shall fail to reject the initial hypothesis. There is insufficient evidence to support the alternate. I'm failing to reject the initial. That means it's like I'm keeping it. There's insufficient evidence to support the other one. Question number 5. This is the last question of the homework that needs proportion stats. We have some peas. We have green peas. We have yellow peas. Do a hypothesis test at this significance level and test the claim that 25% of them will be yellow. They didn't say less than 25, they didn't say greater than 25, so it's simply different from 25%, and that's the one. Okay, they want the test statistic, they want the p-value. Okay, I shall come over here to stat proportion stats 1 sample with summary. Get my hypothesis test set up. What was a success here? It was having yellow peas. And out of how many observations? Well, I feel bad for you if you think that the total number of observations here is the number of green peas. Well, it's not. It would be the sum of all the peas, which is the number of green peas plus the number of yellow peas. That's a total of 546. Super. I have here my numbers. You can hopefully see where they have all come from. The test statistic, negative 0.44. the p-value 0. Let's say round to 4 decimal places, so I'll put, and that's what I have in the, that's all they gave me for the p-value, so 0.6565. Okay, 65% chance I'll be wrong if I reject. That's a whopper of a chance of being wrong. I think I won't reject. I'll be failing to reject because that p-value is so big. Whenever we fail to reject, without exception, if you fail to reject, you do not have sufficient evidence, right? So it's either B or C. It's either B or C, but you have to read carefully. I do not have sufficient evidence to reject. The initial hypothesis. I do not have sufficient evidence to reject the initial hypothesis. Well, it can't even be this one because our hypothesis test wasn't even about being less than 25%. It was about being different from 25%. Question 6. Now we move on to a different kind of hypothesis testing. It has all the same hallmarks as what we just did, but it's hypothesis testing about a mean. Hypothesis testing about a mean. I mean, look at this question. It wouldn't make any sense for me to walk into the patient's room and say, you know, hey, Mr. So-and-so, your blood pressure today is, 50%. Your blood pressure today is 50%. I'm going to have to get you some statins. That wouldn't make any sense, right? Proportions are like percentages. This is completely different than the rest of the previous 5 questions. This is about a mean. Which symbol did we use for mean? It's the mu. Mu. Looks like an M, looks like a U. It's a mu. It makes the sound just like mean. The initial hypothesis is always about equality, and they're wanting me to check whether the mean should be greater than 120. Check whether the mean should be greater than 120. Fantastic. I shall go to T-stats, 1 sample with summary. Again, that's stat. T-stats, 1 sample with summary. Here they would like to know, what sample mean do you want to deal with? Well, from my data set, the sample mean was 123.4. And the sample standard deviation was 15.79029. And the sample size, well, they said that it was 100 blood pressures. That's my sample size. I'm checking to see if that mean is equal to 120 or greater than 120. Compute. Test statistic, p-value. Identify the test statistic to 2 decimal places. It is 2.15. Good job. Identify the p-value, 0.017. Time for the conclusion. It's the same story as before. If the p-value is low, reject H0. Well, my p-value here is pretty low. Pretty low. It's almost 2%, and that's an awful lot lower than 10%. So I have the p-value being low. If the p-value is low, lower than what? Lower than the significance level. If the p-value is low, reject H0. So I shall reject H0. That means there is sufficient evidence to do something. To know which something it should be, I need to know what they're talking about down here. Are they talking about the initial hypothesis, or are they talking about the alternate hypothesis? I want to be able to look at that stuff in blue and say either initial hypothesis or to be able to say alternate hypothesis. Well, guess what? Greater than. That was the alternate. If I'm going to reject the initial, that means I have the evidence to support the alternate. Question number 7. We have here a story about course evaluations. They give me a mean. X bar is the mean. They give me the sample standard deviation, which is 0.57. They give me the number of evaluations they looked at. They would like to know if those course evaluations have a mean equal, or if the population of course evaluations has a mean equal to 3.50. 3.50. They didn't say greater than 3.50. They didn't say less than 3.50, so that must mean they're talking about different from 3.50. The test statistic minus 2.50 the p-value to 3 decimal places, 0.014. Okay, that p-value, it's low, it's nearly 1%, it's bigger than 1%, but it's a lot lower than 5%. So that is a low p-value. And what do I do if the p-value is low? You reject H0. Every single time you reject, there is sufficient evidence. And no matter what you did, no matter if you rejected or failed to reject, the end of this statement is always the same. No matter if you rejected, no matter if you failed to reject, this last part is always talking about reject H0 or support the alternate. Those mean the same thing. If you had a choice between a red car and a blue car, if you said, and you had to pick one of those, no other choices, red or blue, and you say, well, I hate red cars, then that means you're going with the blue one. You might say, I love blue cars. Then that means you're going with the blue one and not the red one. It means the same thing. Okay, so what are they saying right here? There is sufficient evidence to conclude that this statement, student course evaluations is equal to 3.50, which the initial hypothesis or the alternate hypothesis, which one is precisely the statement? Student course evaluation, Which one is the statement? Mean of the population of student course evaluations is equal to 3.50. I do believe that that was the initial hypothesis. Look, it says equal. So, and if we're rejecting that statement, that means we think it's not correct. Question number 8. A data set about speed dating talks about how the speed dating partner would rate their date. Okay. Here I've just been going to options edit and just re-editing the thing. You know, if I didn't do that, you'd have to go back to stat. T-stats, one sample with summary. Okay. What is my sample mean? Well, looks like the average rating was 5.89. That's awful low. On how many women were asked? 193. The sample standard deviation, 1.99. What are they having me test? Test the claim that the mean is less than 6. Less than 6. Less than 6. Here is my test statistic and p-value. Test statistic is minus 0.77. P-value 0.222. That p-value is not low. I mean, 22%. 22% chance of being wrong if I reject it. That's way higher than alpha. I'm going to fail to reject. This is too much risk for me to be rejecting. 22% chance I'd be wrong. So I shall fail to reject. There is not sufficient evidence to reject. So there is not sufficient evidence to conclude that the mean of the population ratings is less than 6. Look at what this says. It says there is not sufficient evidence to support the alternate. Why would I not be in the blue car? Is because I don't hate the red car. I like the red car. I refuse to drive a blue car. Then I must be in the red one. I'm failing to reject the initial one. I'm failing to reject the 0. I'm not saying it's true. I'm saying I don't have any way to dispute it. The only way I can get to the alternate is if I have something to dispute this one. Well, I don't have the evidence to dispute that one. I don't have the evidence to dispute that one. Even if I did have the evidence to dispute that one, this part down here would be the same for everyone. It would either say, reject the initial, support the alternate. What does it say here? It says the mean is less than 6. That's the alternate. We do not have sufficient evidence to believe in the alternate. Question 9. Oh goody, this one comes with raw data. I'm going to take advantage of that. I'm going to say open in Statcrunch. Open in Statcrunch. Why am I getting this? All right, so I imported that data into Statcrunch. You can see it right there in that first column. So bang, I have data now. Instead of going to with summary, I can just go to with data. Stat, T-stats, one sample with data. Where's my data located? It's located right there in VAR1. What you going to do with that data? Well, I'm going to check to see if the concentrations of lead in this medicine is less than 14. Less than 14. Compute. Coming back over here, mu equal to 14, mu less than 14. Identify the test statistic. Oh, that should be easy. It's minus 1.44. Well, what about the p-value? 0.092. Great. What do we think about that p-value? Is it low or not? Because what do you do if it's low? If the p-value is low, reject H0. Well, 0.09 is not lower than 0.05, so I won't be rejecting. I'll fail to reject. If I fail to reject, I do not have the sufficient evidence to reject. If I fail to reject, I do not have the sufficient evidence to reject. Even if I had rejected, I would have the sufficient evidence to reject. They both end the same way, talking about to reject H0, which means the same thing as support the alternate. And what are they talking about here? Less than 14? That was the alternate. So this should say support the alternate. And finally, the last question. Child booster safety seats. They've given me the raw data. I shall open it in Statcrunch. All right, here is my raw data. Stat, T-stats, one sample with data. That's where my data is at. And they want me to do the hypothesis test on, let's see, test the claim that this sample of booster seats is from a population with a mean less than 1,000 head injury condition units, HIC. So less than 1,000. Come back over to here and configure this to say less than 1,000. Super. It's that one, equal to 1,000 or less than 1,000. All right. T-stat is minus 3.18. Oh, they want it to 3 decimal places. So minus 3.1, it's still minus 3.18, 3.180. The p-value to 4 decimal places. Well, that's exactly the number of decimal places that they gave me. And look, it goes 0, 1, 2, 3. All right. 0.0123 is a little bit bigger than 1%. It's a little bit bigger than 1%, but that's a lot smaller than 5%. And what do? Well, if the p-value is low, reject H0. How low does it need to be? It needs to be lower than the significance level. So with my awesome low p-value here, I'm going to reject because my p-value is low. If the p-value is low, reject H0. That means I do have sufficient evidence to support the alternate. Look at how all that stuff in blue says support the alternate, because all of the rest of that mumbo jumbo is captured by the idea that mu is less than 1,000. And I'm now finished. Well, thought I was finished. There's a follow-up question. What do the results suggest about child booster seats meeting the specified requirement? I have strong evidence that the mean is less than 1,000, but one of them is bigger than a, so one of these failed. So it's like I grabbed some booster seats from some kind of place and tested them to be safe. They need to be less than 1,000. One of them didn't quite reach. One of them would not be considered safe, but if these all came from, like, I don't know, the same batch or whatever, then according to our statistical calculations here, we have strong evidence that that batch is indeed safe. And now I'm finished with the homework. This took 42 minutes. So between all of the stuff that I have on Canvas already, by the time I add this video to that listing of resources available to you, there is nothing else that I could show you about how to do week 6. And I'm going to feel pretty confident that if we are still struggling to get the right numbers, I'll know you didn't watch this. That will be my conclusion. Because if you had watched it, you'd probably do it this way. Even if you already knew how to do it by hand, you'd probably do it this way just to save time and make sure you didn't make an error. Good luck.